Here's exercise clamp. Make a copy. I'll call it. Already did this before, I think. I'll call it Zookle 2. Slide 1 is done. Navigate to the Assembly tab. Right-click on the tab and select Rename. Rename Assembly Clamp Assembly. Clamp Assembly. Press Enter. Done. Insert the parts from the Part Studio. Select Insert. There they are. Click the Clamp Part Studio to insert all 3 parts at once. Clamp Part Studio, all 3 parts at once. Now, it just says click the parts into the graphics area and accept, but I think they want it. See, there's the origin, and so we're definitely going to need to set it later. Yeah, it's this step. Use the triad manipulator to move the rod so that the center of the front face aligns to the assembly origin. Okay, so when you do that, oh, I needed to accept the thing first. When you do that, you click on the face where you want it. There it is. Now, I'm going to use that to bring it back to here, but it's tough to see from the angle. So I'm actually going to go, oops, see, I went too far. So I'm going to go back, and now it's pretty close to a line that way. Zoom in, yeah, it looks lined up. Let's bring it down. Let's bring it back. See how changing from trying to do things like that with an isometric view is, and they even show you how far away it is from the origin, I think. Right there, there's the 0. So I want that to be zeroed. Let's look at it from isometric again and see, okay, so we don't have that way, so now we want to look at it from the front. Okay, now it should look like, oh, no, with the corner with the front, right, and top. It looks pretty good, pretty right on there. That is something that I'm getting better at myself. So fix the part once positioned. Slide 5 now. The fixed clamp is fastened to the left end of the rod. Create a fasten mate. So here's fasten mate between the mate connectors located at the center of the end face of the rod and the center of the cut in the fixed clamp is shown. So we want that face and that face. That looks good. And are there any? Nope, there's no offset, so that looks good. Step 6, do the same for the other one. We want this to be, well, they won't show it till I click fasten, so we want it to be, there's a lot to click here, but see, we don't want this inside face. We don't want whatever that face is. No. Oh, there it is. There it is. There's the front, but we want the center right there. And we want that to align with that face so that they're flush. Now we want to insert the 3 parts from the handle. So Did I already accept that mate? Okay. Insert, handle parts, place them somewhere out there, accept the inserting of them. They're in there and they look together, but they're not together. They're not connected. They're not assembled. So let's assemble them. We're going to assemble them by this end is going to mate on the inside there, butting up against it. So is it a fastened again? Yeah, fasten mate. And there's the inside face. Kind of like how they do assemblies in Onshape, Jim. Yeah, it's like they help you make things fit together better instead of like giving you the option to do things that you shouldn't do. Yeah, yeah, yeah. Okay. Okay. This is the cool one. To allow the stopper to pivot about the threaded shaft, create a ball mate. They have some interesting mates too. And we want to pick the rounded face. We want to zoom in to make sure we get it right. So it's not this. That's like the front thing. And it's not that flat two-dimensional circular thing right there. We want so we see that arc. And so that's that one. And then we'll zoom in here and also that roundedness. And we accept. Thing. I think it's almost done. Step 9 to 13. See, but that one should spin if I did it right. I feel like I did not mate that correctly. See, I've got little alerts there. Fasten 3 has an error. Mate needs 2 mate connectors. Well, open it up. Whoa. Oh, because for some reason I may have double clicked. Let's delete that. I know I only have one ball. Oh, maybe it's floating because it's not attached to the fixed yet. So we need this to get on there. Mate the thread shaft to the sliding clamp so that it can slide and rotate with a cylindrical mate. That's the revolve mate. That's cylindrical mate. And we want it to be, got some limits there. We want it to be on this face. And we want it to be on this face. Oop, beep, beep, beep. Don't worry that only the one thing moved right now. We didn't accept it yet, but we need to have limits of -3 in the Z. Oh, that's not the Z. That's just the thing. Sorry. So -3 there and then 0 there. Or was a Z? Yeah. That's the Z max and min, and that's the Z angle. Okay. Okay. Why is there 2? Why do they keep making 2? Oh, good. I just need to close it there. That was the problem. I was closing it, but Or I was hitting solve instead of close it. Drag the instances to see how they move. So this, yes, that's good. Although that should probably have some limits on it too, because you can see it moves through the piece, but that's pretty cool right there. Kind of just ignores the threading. Doesn't really have a threaded mate right there. It's as if it was just a rod, but that's okay. To check your answer, reset the slider, ball, and cylindrical mates. Right-click on each mate and select reset. Why do I not have one called slider? Oh, this was not supposed to be a fastened. That was supposed to be a slider. Can I change? Aha! I can just go in and change it there. Sweet. Now it will slide. Now I will reset it. Is everything else reset? Reset and reset. No effect yet because that one didn't change. So now this is where I check the center of gravity of this. Hold down shift to that, or center of mass, that is. Let's see. Begin self-check. These numbers don't look exactly the same, and I don't know why, but I'm not worried about it. Choose the best answer. So which one's closest? So I got my biggest number is a Z. So which ones have the biggest number as a Z? A and C. My next biggest, or my smallest number is the Y. So biggest number is the Z, but smallest number is the Y. That is A. See results. And I got it right. See, that's what we're saying. Like, don't worry about having the exact number. Just kind of say, okay, well, which is the bigger, which is the middle, and which is the small. Select your self-check thing kind of that way, because getting the center of mass to be exactly the same is very difficult because it's based off of the origin. Okay, sweet. And that is it.